Alright, so video 2. Let's talk about this. We're talking about things moving at a constant speed in a circle. Now, think about this. This is like if you were in class, I had the little kind of, I don't know, little stuffed toy things on the string. And if you get them going at a constant speed, I want you to think about kind of how that would look. Or, of course, the giant lizard, which you were supposed to look at, the GIF, however you want to say it. That's a giant lizard. Now, this is not the greatest drawing, but this is supposed to represent, you've got an infinite number of points along that circle. Ooh, that's not very good. This is supposed to be something going in a circle. Let's say it's going clockwise, so you're spinning around the circle like that. And this is all supposed to be in a circle. I'm sorry, that's ugly. Okay, but it is what it is. That's a circle. That's the path. It's moving. All right, and this is the center. All right, so let's look at this. If you let go of it right here, like if it's that big lizard thing getting around, let's talk about which way it would go. Now, this isn't a constant speed. That means that this, your magnitude of velocity, does not change. So you're going to have, if you let go of it right here, if you think about, if you get something, just twirl it around a circle, and then you let go, and you let go of it like at this point, it's going to go this way. And then it depends if it's off the ground or whatever, it'll just keep, at that point, the circle thing's not relevant anymore. So that means if it goes that way, at this point, whoops, this should be the same length. I was calling these speed arrows, which should be, sounds strange because that shouldn't make sense to you because it doesn't make any sense. Because remember, speed is just, it's not a vector quantity, so you wouldn't need an arrow. Okay, so it would be here. So like if you're at this point, think about which way would it go? Up. Okay, so that means at this point, guess, yep, down, and then somewhere in between on these. And this, you've got an infinite number of points. These are 8 and not very well drawn. So you're looking at that. And then, so this is your, actually, since these are arrows, guess what I need to take off of this magnitude of velocity right here? These, because I do have a velocity. And because I have a direction. It's not just like it's just, something that's just traveling the same speed forever, like in space or something. So this is your velocity. And this velocity is going around a circle. There is another name for this. Whoops, I lost this one. That I will teach you when we get to a later unit. This is the stuff we're dealing with right now, by the way, is moving at a constant speed in a circle. You can say that this constant speed is also a uniform speed. Uniform being constant, or, the same. So we will call this uniform. It's moving in a circular. It's moving in a circle. C-I-R-C-L-U. It's uniform circular motion. I will probably ask you tomorrow about this because what I will abbreviate this as is UCM. Uniform circular motion. That means it's at a constant speed. It is not speeding up or slowing down as it goes around the center of something. Okay, so on the velocity, we're going to call that for right now V, CIR, or you can just V sub C. So that would mean circular velocity. And there's another name for this, but right now when we're dealing with UCM, uniform circular motion, we're going to call it circular velocity in this class. All right. That will become obvious to you later on in the year why I did that, and it's actually to make things easier on you. So, anyway, so these all should be about the same thing. So let's first of all look back at what acceleration is. Well, the way I was showing some people, if you remember this equation, I don't know if you remember how we derived it, but this is going to be velocity final equals velocity initial plus acceleration times time. I'm just going to solve this back. So that means, therefore, subtract this, subtract that. Okay. Anyway, that gives you change in velocity, kind of over. You don't need to show all this. I'm just did it. Equals acceleration times time, divide the time. So, hey, look at that. That means acceleration. Hopefully you remember this. Think about the graph. Acceleration equals change in velocity. It's technically change in time. That's a time interval. More on that in a second. Okay, so let's look up here. Is your velocity changing? Yes, it is. Your velocity is changing. Now, the magnitude, this part, your speed, your magnitude of velocity is not changing because you're in uniform circular motion. But since your direction is changing, your velocity is changing. Okay, so therefore you have acceleration. It is accelerating. All right, I'm going to get to the acceleration more in just a second. I just kind of wanted to show you that. And let's do the equation for your circular velocity. Actually, I'm going to stop this one here.